So welcome students. So in the one of the last lectures that we are doing in the series of lectures for geometry IOQM, this is the lecture where we would be learning distances between special points, in center, ortho center, circumcenter. So these are the points that we are looking for. Fine. Now one of the primary objectives in all these questions would be to use either geometry or cosine law. The important aspect in all these things, in all these say distance between, suppose I say in center and ortho center, in center and circumcenter, circumcenter and ortho center, circumcenter and in center and ortho center, centroid is altogether a separate issue because these three involve angles. So angle chasing might help you in dealing with them. In the so far as centroid is concerned, it's bit different because when we draw medians, they generally don't involve angles. You get midpoint, so that will primarily be a notion of length chasing. Here we will use length chasing and angle chasing and then proceed. For example, distance between or let us first standard is distance between in center and circumcenter. One way to deal with them is to deal with this specific issue is because it involves two circles, angle chasing and using properties of circle. Other is of course, as I told you earlier, angle chasing. So let us first deal with it in pure geometrical way, then we will deal with it in using trigonometry, because in other cases trigonometrical approach on occasions is of great help. So suppose this is a triangle, this is a circle, and let us inscribe a triangle in it. Okay, now let me also draw it in circle. Suppose this is its in circle. So A, B, C is the triangle. Say I is in center of this triangle, and say O, for example, let this be the circumcenter. So we have to find distance between in center and circumcenter. So this approach primarily uses the notion of geometry. So what we do is that we draw AI and say let it meet here at say L, and then from L we draw diameter of this larger circle, that is the circumcircle, and let this point be M. Okay, now we have to find IO. So what we do is that we draw I, the diameter passing through I, and let it be PQ. The perpendicular is say D. One thing that you can very easily see that AI into IL is OP, we have to find IO. is equal to IP into I. Okay. Because these are for concyclic. Now the purpose is to determine AI into IL. Now this angle is 90 degree and suppose this angle is alpha. This angle is 90. Which other angle you know is 90 degree? See, this is diameter of the circle. So let me join B and M. Fine. Now we can say these two angles are equal. So triangle ADI and triangle ADI MBL are similar triangles. Fine. So from here I think we can find AI. No, it will not involve IL. Look, let me see what do we get. AI is opposite to 90 degree and ML is opposite to 90 degree in MBL is equal to ID upon BL. So AI into BL is ID into ML. What is ID? Small r. What is ML? This is the diameter, 2r. So what is left is to determine BL, relation between BL and IL. BL and IL. Okay. Now, since this is the in center, okay, so we can find this angle. Suppose this angle is B by 2, isn't it? Uh, uh, See, this angle is A by 2, A by 2. Okay. So chord CL subtends an angle A by 2 here. So this will be A by 2. Okay. B by 2. So this angle is C. Angle in same segment. So this is A plus B by 2. So this is also A plus B by 2. So which two sides here are equal? These two sides are equal. IL and BL are equal. That serves our purpose. So from this triangle we can say IL and BL are equal. So AI, BL is nothing but IL. So this is 2RR is IP into I. What is IP? Now if this distance is D, IP is R minus D. And what is IQ? R plus D. D is the distance we are looking for. So 2RR is R square minus D square. So D square is okay. So the distance between in center and circumcenter is r square minus 2r. Fine. This is a very good way to say that r is always greater than equal to 2r. And we did it some other way also, but radius is always at least twice the in radius. In a equilateral triangle, they coincide, so this becomes 0. R is equal to 2r. Fine. So this is a geometrical way because it involved circles, two circles. We could use in fact, everything here we use is geometry. We could have proceeded it using trigonometry. In trigonometry, or so to say in algebra, the algebraic ways are generally consistent. That is the thing. Therefore, you can apply it. It generally requires less ingenuity to apply methods of trigonometry because processes are more or less fixed. Okay. Now, if we move ahead and say, sir, now let me tell you the same thing using trigonometry. So, how do you do it? This is a triangle and say this is your circumcenter, this is your incenter. Okay. I, O. A, B, C. So, this distance OB is capital R. This distance R is R, sorry, cosec B by 2. And our purpose is to determine this angle and use cosine law. That is how we proceed here. So, see, the process is very simple. Now, how do you get to this angle? This is circumcenter. So, if this is circumcenter, this angle is A, so angle at the center is 2A. So, this angle is A. So, this angle is pi by 2 minus A. And what is this angle? B by 2. So, our required angle theta in the diagram is B by 2 minus B minus pi plus 2. So, A plus B, see, A plus B minus pi is minus C. So, what do you get here? A minus C by 2. Now, IO square is R square plus R square upon sine square A by 2 minus 2 R into cos A minus C by 2. Okay. So, what is this? This is 4R square, sorry, R is 4R sin A by 2, sin B by 2, sin C by 2. So, this would be 16R square sin square B by 2 minus 8R square sin B by 2, sin C by 2. into what you are left with is cos A by 2 cos C by 2 plus sin A by 2 sin C by 2. So, this is R square. Now, see sin square A by 2 sin square C by 2 plus 8R square sin B by 2 sin C by 2. And what you are left with is sin B by 2 sin C by 2 minus A minus C B by 2 na. So, sin A by 2, so what you are left with is B by 2 C by 2, and this is sin A by 2. What this angle is B by 2. Okay, this angle is A, so this is pi by 2 minus A, absolutely fine. B by 2 minus pi by 2 minus A. So, B minus pi plus 2A. A plus this angle is A minus C by 2. Is there some error in between? Sin B by 2 sin C by 2. This is not cos B by 2 cos C by 2, isn't it? Oh, this is B by 2. Okay. Very sorry. This is A by 2. A by 2. A by 2 and cos A by 2 . Okay. So, what is IO square? So, IO square is R square plus 8R square. This is minus cos A plus C by 2. So, it becomes minus sin B by 2. Minus, so minus into 4R sin A by 2 sin B by 2 sin C. So, this is algebraic method. Everywhere this is how we will proceed. So, this is the distance between in radius, in center and circumcenter. Of course, this is a more elegant way to deal with it. I just told you this because in others, see the process will remain the same. If you want to find distance between orthocenter and circumcenter, this is the process we will follow. This is the good thing. Of course, it is algebraic, so it is based on processes. In geometry, you always require a bit of ingenuity, a bit of niche, a bit of elegant thought to deal with things. Fine. So, this is to be kept in mind because the expression is reasonable. Suppose I say, let me solve a problem in this, the direct result of this would be in an isosceles triangle, angle ABC is equal to angle AC. The ortho center of triangle ABC lies on its incircle, or let's say let's circumcent. Incircle. Find cos of angle. So in this problem, I will tell you how to find the distance. Okay. Now, this is a simple figure. Because it is an isosceles triangle, this will be the angle bisector, this will be the altitude. What you are given is that the altitudes are like this. This is H, this is I, this is D. There are ways and means to deal with it if you remember our last class. One thing is we say that this distance is small r. For that we need to know distance between in center and ortho center. One way to deal with it is like this. Other way is we know distance between ortho center, sides and vertices. Distance of ortho center from this. I hope you remember in last class we wrote it as 2r cos B cos C. This is in this particular case 2r. Okay. So R B is equal to C is equal to pi minus A by 2. Okay. So what you will do is R sine square A by 2, isn't it? Is R sine A by 2, sorry, 4R sine A by 2, sine B by 2, sine C by 2. So sine A by 2 is 2 times 1 minus, sorry, 2 sine square B by 2 is 1 minus cos B. What is cos B? Sine A by 2. Sine A by 2 is 2 minus 2 sine A by 2. So sine A by 2 is 2 by 3. If sine A by 2 is 2 by 3, we can say cos A is 1 minus 2 sine square A by 2. This is 1 by 9. This is how we used it. Now, if we wanted to use this distance, so insofar as this problem is concerned, we didn't require the expression if we remember this, the distance of ortho center from sides, which we did in our previous lecture. I hope you all remember it. Now, we could have also said that this distance is equal to small r, distance between ortho center and in center. So now, let me first write an expression for ortho center in center. Okay. So distance between ortho center and in center. So we will proceed in a similar manner. H. Fine. Now you have in center, so say this is the in center. Okay. Say this is the in center. Okay. So you draw this line. B, C, A. Okay. Now, distance of orthocenter from B is 2r cos B. This is r cosec B by 2. This is B by 2. And what is this angle? If we extend it further, this is 90, this is C. So this angle is 90 minus C. So R angle theta is 90 minus C minus B by 2. So this is 2 180 minus 2C minus B. This is 180 this is A minus C by 2, isn't it? So we know all the requisite things. Now we will apply the formula. 4r square cos square B plus 4r cos B into cos of A minus C by 2. You see the expression, okay, may not turn out to be as beautiful as has been the case with other situations, but the process that is being followed remains the same. What we do is that we write it as 1 minus sine square B and then we tend to manage it. So let me write it formally. 4r square cos square B plus 16r square sine square A by 2 minus 16r square cos B sin A by 2 into cos A by 2 cos C by 2 plus sin A by 2. So this becomes two 4 and 16r square minus cos A by 2 sin A by 2 minus 16R square. Say cos A by 2 sin A by 2, that becomes sin A. So 4R square. So sin A sin C cos B upon 4 minus cos B. So what you get in turn is, let me write it from here. What do you get is 4R square cos B into cos B minus sin A sin C. Isn't it? And what you are left with is 16R square sin square A by 2 sin square C by 2 into 1 minus cos B. Now here, if you think correctly, see, let me write it here, 4R square cos B. What you are going to get is minus cos A cos. Cos B is minus cos A plus C minus sin A sin C minus 32 2 into 4R sin A by 2 sin B by 2 sin C by 2 whole square. And what is this? Minus times cos A cos C minus sin A sin C. So sin A sin C gets cancelled out. So what we are left with is 2R square minus 4R square cos A cos B cos. So this is the expression. Okay. So this is the distance between in center and ortho center. This would have been a tedious exercise. Suppose we know it and we say this is equal to small r square. That I think would have taken us a bit, bit longer to resolve the previous question. Fine, but the process remains the same. And similarly, distance between ortho center and, that is I think a reasonable expression. Distance between ortho center and circumcenter. And circumcenter. We will again draw the same diagram. This is the utility that we have. This is the utility of trigonometry or algebraic methods, that they are consistent. The situation, depending upon the situation, we don't generally change the methods. Whereas in geometry, corresponding to a situation, we need a bit of ingenuity to deal with them. Suppose this is ABC. Now we suppose circumcenter is this point. Fine. If this is O, this is R, this is 2R cos B. This angle is pi by 2 minus, we just did it, I think some. This angle, we just saw it. What is this angle? This is C. This is pi by 2 minus C. So this angle theta is pi by 2 minus C. This is A minus C. Okay. Now, OH square is R square plus 4R square cos square B minus 4R square cos B into cos A minus C. So this is cos A plus C with a minus sign, that is why we have taken it as common, plus cos A minus. Okay. Now this is R square minus 8R square cos A cos B cos. A better expression, much better than the previous one that we have got. Isn't it? So these are the distances. We must know the method. See, some beautiful questions may appear here. Now somebody may say, I think I remember one beautiful problem asked earlier, that if this triangle is isosceles, okay, so we know all the angles. Now from knowing all the angles, we are able to determine some relations. Fine. So say one of the triangles is isosceles or stuff like that. That is a very relevant thing. Okay. This is, suppose this is asked, orthocenter and circumcenter. Now if this triangle is isosceles, so these two sides or these two sides are going to be equal. These two are generally not equal. Okay. Suppose somebody says circumcenter lies on, just as the problem we did, I thought it is the problem of where we will use R square minus 2RR, but unfortunately I used orthocenter. Distance between orthocenter and in center we have found out. If somebody says distance between circumcenter and in center is small r, or somebody says circumcenter lies on the in circle, so that will give you R square minus 2RR is R square. And somebody may ask you what is R by R. So you can use quadratic to solve it. Or now once we know the distance between orthocenter and circumcenter, so we know that centroid lies on this line and this ratio is 1:2. So OG and GH is calculated from here only. Okay. OG, suppose we want to calculate OG and GH, then this will be the thing that we will be using. Cos A cos B cos C, is there a good expression for cos A cos B cos C? What is R cos A? 90° A. This is R cos. This is R sin. Is there a good expression for cos A? But distance between OG and GH would be simply 1/3 and 2/3 of these distances. Suppose somebody says find GH, so it will be 2/3, or say if you take square 4/9 of this. Cos A cos B cos C, is there a good expression for cos A cos B cos C? In terms of sides, somebody says, in terms of sides, is there a good expression? If we write a square, that will be a very big thing to write. That is definitely not something that we should opt for. Cos A is B square plus C square minus A square upon 2BC. That will be too big an expression. Leave it, sir. I roughly recall that it is a good expression. Cos A cos B cos C. No. Now, so these are distance between special points. That was the purpose. Now, this is all in all the theoretical notions that we needed to know for what we have to do in geometry. Pure geometry we went through. We went through stuff that are required from very basics. We went through Seva's theorem, Menelaus theorem. Then we did a bit of trigonometry followed by SOT. Basic proportionality theorem was also discussed. So, all in all, what we have done is that we have covered almost everything. Definitely there is some lack of practice in the classes, in the sessions that we took. So, in 1 or 2 sections that we are going to take further ahead, we will take only problems. More or less all the theory is covered. We will take up some practice sessions of problems that could be expected, because now we will not be confined by the notion that what we have taught, what is remaining, what is not remaining. Everything that almost needs to be covered to the best of our knowledge has been taken care of. Moving forward, we will take up problems where we may use trigonometry, where we may use geometry as the situation arises. Okay. So, I hope this session where we have learned distance between special points would have been of some help to you. Moving forward, I hope you will join us in those practice sessions and will further accumulate and utilize the knowledge that has been acquired through this series. So, thank you very much and rejoin us for our practice sessions. Thanks a lot.